Okay, in this question, we will be dealing with a different style of setup of charges. They will come as 4 charges making a square. Again, I'm asking for the net electrostatic force acting on Q4, this our Q4, because of the other 3 charges, Q1, Q2, and Q3. Now, all these 4 charges have the same magnitude and the same type. They're all positively 100 microcoulomb, and the distance on each side is 1 meter. Okay, so for this question, to do such thing, we have to remember that when we apply Coulomb's law as an F equal the constant Q times Q over the distance square, that means we do have the magnitude of every single charge, and also we need to make sure that we have the distance between every single scenario. So I know that the distance between Q3 and Q4 is 1 meter. I know the distance between Q2 and Q4 also 2 meters. And I can do the math to find that the distance between Q1 and Q4 is the square root of 2 meters. So that's a 1 meter, and also this one is 1 meter, right? Now, let's start with the calculation. I will go first with calculating the force generated because of charge 2. So I will say F on 4 because of 2, that will give me 8.9 10 to the power 9 multiplied by 1 10 to the power minus 4 squared divided on the distance, which is 1 square, and that will give me a 90 Newton. Now, to make sure we know the direction, now the Q2 and Q4 are positively charged, and our target is Q4. So from there, I will decide, or I can show the direction of this electrostatic force. So it is a repulsive, so it will be in this direction. That is the direction of 4, the force of 4 because of 2. Sorry. Let's erase this one and fix it again. So it will be, it's like this. It is the force on 4 because of 2. Now, if want to calculate the force on 4 because of 3, I don't need to go into all these calculations. I can tell easily it will be a 90 Newton as well. How did I know that? Because the distance between Q3 and Q4, it's exactly the same distance between Q2 and Q4. The magnitude of the charges is exactly the same. So I will have everything perfectly equal to each other. So the force of charge, the force generated on 4 because of 2 will equal the force generated on 4 because of 3, except the direction will be different. In this case here, this one will be negative. How? Because it will be going to the south or downward. That will be the direction of 4, 3. Because the relationship, it's a repulsive electrostatic force, and it will be pushed away. And this negative telling me the direction of this force. Now for F41, the same way, it's an 8.9 10 to the power 9 multiplied by 1 10 to the power minus 4, and it's squared because they are the same charges, divided on the square root of 2, and don't forget the square of the r. Now when we do the math, it should give me 45 Newton. All right. Now, where is the direction of the F41? Again, this is a positive. This is also positive. For Q4, it will be a repulsive. So I'll start from my target here, and that's a repulsive force. That's the direction of the electrostatic force on 4 because of 1. Now, as you can see, the force generated on charge 4 because of 1, it's making an angle with the x-axis. We can say it is 45. It's a square being split. The angle, the 90 degrees being split. That means we can analyze this vector or this force, the 4, 1, into 2 components. So I can say the force 4, 1 x equal F4, 1 cosine 45 degrees, and the force on 4 because of 1 on the y side or y component, it is 4, 1 sine 45 degrees. Okay, and it's easy to be calculated. That's gonna be giving me 32 Newton. This one gonna be the same. It's the same magnitude, the same angle for the sine and the cosine. And that's gonna be negative 32 Newton. Again, the negative representing the direction. Okay. Now, if we're gonna make it more clear, let's have another page. This is the scenario I have. I have my, let's use the blue, that's my charge Q4. I have the F42. I have also the F43. For the 2 components coming from the force generated because of charge 1, I will have the scenario like this. I'll have F41x, and I will also have F41y. These 2 coming from this vector, the F41. Okay? Now, to find the total electrostatic forces on the x-axis and the total forces on the y-axis, we should do this one. So the total forces on the x-axis, it will be F42 plus F41x. And if we do the math, that will give me 90 plus 32. It is positive 122 Newton. Okay, now the total forces on the y-axis, it will be F43, okay, plus F41, the y component, and this should give me, it's a minus 90 minus 32, it's a negative 122 Newton. Great, so I know my total forces for each component, the x and y. So if I want to simplify things, I can draw that this is the total Fx going to the positive side. This is the total Fy, and this one will be my net electrostatic force acting on my Q4 charge. Now we can simply say the F net, or the total electrostatic force, will be Fx squared plus Fy squared and the square root. And if you square this value and this value, add them up under square root, it should give you something around 172.5 Newton. So that will be the answer of our question, which is find the net electrostatic force acting on Q3. All right, I hope you find this example useful, and the methodology, it's really clear and handy. Thank you very much for your listening.